Hey everyone, my name is Edward, and I'm a machine learning engineer at Explosion. Today, I'd like to show you how to annotate data in Prodigy for span categorization, or in short, spancat. We will be looking at Prodigy recipes for spancat, features to help with consistent annotation, and ways to speed up the process with patterns and training temporary models. Spancat is our new spacey component that can extract and classify spans from text. These spans can be long and overlapping, as seen in this example. So we can divide spancat into two parts, the suggester and the classifier. The suggester is a function that extracts span candidates from the text and feeds them to the classifier. You can write these suggester functions yourself, and they can be completely rule-based, depend on annotations from other components, or use machine learning approaches. The default built-in suggester function is the n-gram suggester, in which you can define which n-gram sizes you want to get suggested. For every extracted span, the classifier predicts the probability for every label and includes 4 steps: embedding, span extraction, pooling, and scoring. Named entity recognition is more effective for proper nouns and self-contained expressions like person names or products, because it predicts single token-based tags and takes advantage of clear span boundaries. However, it's usually not the right tool for other types of phrases, sentence fragments, and overlapping spans with less consistent boundaries. So let's do a quick summary between the differences between NER and spancat. First, we have explicit control of candidate spans. You can define rules on how spancat obtains likely candidates by writing suggester functions. Through this, you can bias your model towards precision or recall, customizing it further depending on your use case. Second, access to confidence scores. Unlike NER, a spancat model returns predicted label probabilities over the whole span, giving us more meaningful confidences to threshold against. At last, less edge sensitivity. NER models may find it easier to learn tasks where the most informative word is near the start of the entity, whereas the spancat uses the full context of the span to catch informative words that are deep within the entity. Let me present you our little dataset, which we're going to annotate today. We'll be using food recipes to annotate 2 labels, ingredient and instruction. You can find and download the dataset from kaggle.com. Let's take a closer look at our labels. For ingredient, we're going to label anything that is eatable or processed, and that is used in a recipe. However, there are some cases which are not fully clear. For example, combine berries with sugar to create the berry-sugar mixture. In this case, berries and sugar are ingredients. But so is berry-sugar mixture, because it's a processed ingredient that is eatable and used in a recipe. But this example, put the kebab on the grill, is not, because kebab is the end product of the recipe, and we will exclude those. For instruction, we will limit the label by saying that these spans are required to contain at least 1 ingredient. So, preheat the oven to 200 degrees is not an instruction because it doesn't include any ingredient. But combine lemon and sugar is, because both lemon and sugar are ingredients. We will also try to make the instruction spans as short as possible. This means that we won't include any extra information which we don't think that are important. So in this example, combine chicken and sauce in a bowl, we will exclude in a bowl, because combined chicken and sauce is all we need. We will use our annotated dataset in later videos to create a little food app that might tell us which ingredients go well with apple, for example. So I've prepared a JSONL file with 25,000 recipes, which we can then use to annotate our 2 labels. Let's have a look. Every recipe is a JSON object. The key text includes the full recipe text and is going to be displayed in Prodigy. Using JSONL is very effective, especially when working with larger files, because the JSON objects are read as a stream instead of loading the whole document first. Besides the text key, we can also add the meta key that can be used to add additional information. For our case, I've added the recipe name as additional information. Before we start, if you want to follow along or just experiment with SpanCat yourself, we've prepared a Spacy project with all the assets and workflows. You can find the link in the description. Let's start annotating with the first Prodigy recipe, spans.manual. If we want a short overview and description of the recipe, we can type in Python m prodigy spans.manual and help. This command gives us all possible arguments that you can use. For spans.manual, we need the name of the database to save the annotations to, a Spacy model, the annotation data, and our labels. Let's clean our terminal and type Python m prodigy spans.manual, a database which we call food recipes, then a blank English Spacy model which only includes the tokenizer, our food recipes, and our two labels, ingredient and instruction. Welcome to Prodigy. On the left side of the screen, we have all the information about the current session, the dataset name, language, current recipe, and how many annotations we've accepted, rejected, or ignored. We can also see the food recipe and the two labels that we defined. If we scroll down a bit, we can also see the recipe name, which we defined in the meta key. We currently have our ingredient label selected and can annotate ingredients. After we're done with the ingredients, we can annotate instructions. Let's speed it up a bit, until we have around 20 annotated documents. And always remember to press the save button. Consistency is very important when creating a dataset. This is why it's helpful to have annotation guidelines ready, especially when having multiple annotators working on the same project. We can add such guidelines in the prodigy.json file. You can use the prodigy.json to configure different aspects of your Prodigy, for example, theme, shortcuts, layout, and more. In our case, we add the instructions key with the reference to our instruction file, which can be either text or HTML. Let's create a simple HTML file with a short description of our two labels. So we will create a simple div block and add a paragraph in which we type the description of our first label, ingredient, and just say foods that are used in a recipe. In the other paragraph, we will add the description of the instruction and instructions that contain at least one ingredient. Now in Prodigy, we can see a question mark symbol on the left that when pressed displays our instructions. One quick note about how to use Prodigy JSON files is that you either have to include them in the same directory as you run Prodigy, or you can configure them globally. You can read more about it in our Prodigy docs linked in the description. We saw that annotating with spans.manual can take a while. So, to speed things up a bit, we can use patterns. They can be used to pre-select entities based on matching rules, which we can write ourselves. The matching is based on Spacy's matcher and can include different attributes like lemma, lower uppercase, and more. A pattern added to the matcher consists of lists of dictionaries, and each dictionary describes one token and its attribute. So let's create our own pattern.jsonl file with some examples. The first pattern gets the text attribute with the string sugar. This means that sugar will be matched. We will also assign the label ingredient to it. In the second line, let's use the attribute lemma with the matching string berry. This means that every token whose lemmatization is berry is going to be matched. For example, berries. Let's add other patterns with the simple text attribute to catch yogurt and blueberries. So in this example, we've written our patterns by hand, but you can definitely use previous annotations or existing datasets to fill up the JSONL file. To add these patterns, we first need to use a model which can perform lemmatization. So let's use ncore web small and then add the pattern parameter with the reference to our file. Now in Prodigy, we can see that the matcher pre-selected some spans for us. We can also see that it matched berries because we defined the lemma tag for berry. Another good way to speed up the process is to train temporary models. We can use them to predict our two labels on the data and correct anything that was labeled wrong or not labeled at all. Let's train our first temporary model with our annotations. By the way, Prodigy automatically generates the best n-gram sizes based on our annotations. Let's get a quick look into the train command first by typing python m prodigy train and help. Alright, let's start training by typing python m prodigy train, the output directory, our spancat database, and a evaluation split of 25%. This means that 25% of our annotations are used to evaluate the metrics. The training logs the loss of the spancat and the aggregated metrics over our two labels that were evaluated on our evaluation dataset. This means we have a f-score, precision, recall, and a general score, which is the weighted average of all the other scores. Because this is going to be a temporary model, we don't need state-of-the-art performance here. And an f-score of around 0.45 is more than enough for now, because it will help us to annotate more data anyway. With the recipe spans.correct, we can use our temporary model to let it predict the labels on the data and then correct manually if anything is wrong. Now in the terminal we write python m prodigy spans.correct, our database food recipes, the directory of our model, our data, and our two labels, ingredient and instruction. Now in Prodigy, we can see that the model already predicts some spans. Some of them are correct and some of them are wrong. We're going to correct everything that is wrong and label anything that hasn't been labeled yet. This way, you get a good feeling about the capabilities of your model, its strengths and its weaknesses. And you also get a good insight into your data, see what works and what not. You can repeat the process with training temporary models until you're happy. But keep in mind that creating datasets always requires time to develop with many iterations. We can now export our data to the spacy format to further work with it in spacy, or we can simply train our model here in Prodigy. And now for the export, we're going to type python m prodigy data-to-spacy, the output directory, our spancat database, and a evaluation split of 25%. This means that the command will export two spacy files, one for training and one for evaluation. Alright, in this video we had a small look into how spancat works and how it compares to spacy's NER. We also looked at interesting Prodigy features like the meta key or the instructions to help with consistent annotations. And we looked at some ways to speed up the annotation process with patterns and temporary models. Spancat is great when it comes to longer and overlapping spans. And in the upcoming videos, we will be further working with it in spacy. So I hope you're excited, I hope you had fun watching, and we see us next time. Bye.